Electrolysis Part 1, that's Unit C2, Section 7. By the end of this section, you will be able to describe and explain when and why ionic compounds conduct electricity, what happens to ionic compounds when they conduct electricity, to be able to write half equations for these changes, describe what happens if a solution of an ionic compound is electrolyzed, and to link the changes that occur in electrolysis to oxidation and reduction. An electric current is the flow of charged particles. Ionic compounds are made up of charged particles called ions. Make sure you're very careful with your language here. The compound is made up of ions, not atoms, not molecules, not electrons, but ions. In a solid, these ions are in a fixed order and are not able to move, so solid ionic compounds do not conduct electricity. But if you melt the compound, the ions are free to move and carry the charge. And the same is true if you dissolve the compound in water. The liquid that conducts the electricity is called the electrolyte. Did I mention key words? Examiners' reports mention candidates being penalised for talking about the atoms or molecules moving to carry the charge, or for saying sodium conducts when they mean sodium chloride. So do be careful. So that is why they conduct, but what happens when they do? Remember, opposite charges attract. If you aren't sure of the charges on the ions, then you can look them up on the datasheet. It could save you a mark in the exam. In the case of sodium chloride, the sodium ions are attracted to the negative electrode, and the negative chloride ions to the positive electrode. Electrolysis splits up compounds into the elements that make them up. When stating what will be made, don't forget to change the end of the name of the negative ion from "ide" to "ene". "Ide" at the end means that it's part of a compound. "Ene" means that it is the element. And if you really aren't sure of the name of the element, you can look it up on the periodic table, because some, like oxygen, don't end in "ene". We can write an equation to show what happens to the compound, but the change really takes place as two separate changes, 1/2 at each electrode. Don't forget to check that you've got the ions right using the datasheet. At the negative electrode, the positive ions gain electrons to get rid of their charge. 1 electron is gained for each positive charge that they have. At the positive electrode, negative ions give away 1 electron for each negative charge that they have. Remember, in almost all cases, the element that you form will go around in pairs, like Cl2 or O2. When this is the case, you're going to need to start with 2 of the negative ions. You can see the same ideas being applied to a different example. Magnesium oxide is made up of Mg2+ ions and O2- ions. The Mg2+ ions will need to gain 2 electrons. The O2- ions will give away 2 electrons each, and you need 2 of them to make O2, so 4 electrons are given away. In some books this is shown as 2O2-, take away 4 electrons to make O2, which is an alternative way of showing it. Exam questions often only require you to fill in the gaps, normally by adding in the electrons. If this is the case, don't add in other elements. Electrolysis of solutions can give slightly different results. A molten ionic compound only contains one substance, usually only made of two different elements at GCSE level, but a solution of an ionic compound will also contain water, which will make H plus and OH minus ions. This gives you a choice of two ions that could be discharged at each electrode. In the case of zinc chloride solution, there are Zn2 plus and H plus ions, and Cl minus and OH minus ions. You need to be able to predict and explain what is made at the negative electrode. In this case, H plus ions could be turned into hydrogen, or Zn2 plus ions could be turned into zinc. The least reactive element is the one that's made. Find the two possibilities on the reactivity series on your datasheet and choose the one that is closest to the bottom. And that's often hydrogen. Only copper, silver, gold and platinum are below hydrogen on your datasheet. You need to say what oxidation and reduction are in terms of electrons being gained or lost, and then link these to the half equations that you have written. Use the oil rig mnemonic to help you remember it. Reduction happens to the metal ions and always occurs at the negative electrode where electrons are given to the ions. Oxidation always happens at the positive electrode as electrons are taken away from the negative ions. Oxidation is loss of electrons, reduction is gain of electrons. That explains how electrolysis works, and now we're going to look at the uses of electrolysis.